Hello, ladies and gentlemen. I am delighted to be here and share some of my excitement with you. I am a postdoctoral in Professor Alan Zheng's team in Jinan University. Today, my topic is about one of our team's recent work, namely a newly integrated VOC source profile database in China. As we all know, VOCs are tens of thousands of organic species with different molecules. They are important precursors of ozone and PM2.5. Therefore, it is necessary to identify VOC species. Researchers use various instruments to measure VOC species from both emission sources and ambient air. All the measured species showing mass percentage is called the VOC source profiles. VOC source profiles play important roles in air quality management. It can be used for creating speciated emission inventories, estimating air toxic emissions, providing inputs to source appointment and air quality models, and forming effective reactivity-based control strategies. Therefore, some developed countries and regions have established VOC source profile databases. For example, the US EPA established the SPECIATE database, which contains more than 2,600 profiles, and have initially formed a quality evaluation system. In China, Mo developed the first VOC source profile database in 2016. However, due to the lack of localized profiles, only about 80 profiles from some major sources are included, which is far behind the SPECIATE database. Actually, we also found some other limitations in using VOC profiles in China. For example, some profiles fuse multiple types of emission sources, while some profiles are not representative for emission sources, making the profiles difficult to apply in emission inventories and models. In addition, some species in profiles were missing or underestimated. Some measured species were quite uncertain in different profiles, and there is a lack of research on the quality assessment of the localized profiles. Our team has been working on the development of VOC source profiles, speciated emission inventories, and air quality modeling for almost 15 years. In order to solve these above-mentioned application problems, and to guide the following measurement of source profiles, in recent years, we have been working on the update of VOC source profile database in China. I would like to share with you about some of our primary results in the following slides. We carefully reviewed nearly 500 domestic profiles so far, from both published literature and our previously measured profiles. We found the existing profiles in China are mainly from road mobile sources, industrial processes, and solvent use sources. After that, the profiles were classified by emission sources to match the emission inventories. Next, quality evaluation was carried out based on the representativeness of the technicians, the emission sources, the sample errors, and the discrepancies with similar emission sources. Moreover, profiles with high quality but missing VOCs were revised. Finally, the dataset containing about 360 VOC source profiles. For better application in inventories and models, we developed integrated profiles for 8 major sources, as well as 100 sector-based sources. The following are the characteristics of some integrated profiles. Among the 8 major sources, Stationary combustion and biomass burning are dominated by aromatics and VOCs. Solvent use and industrial process are mainly consisting of aromatics, VOCs, and alkenes. On-road mobile sources and storage and transportation sources are alkalis dominated, while non-road mobile sources and cooking are dominated by VOCs such as formaldehyde and acetaldehyde. The second-level sector-based profiles in different sources are also quite different. Here, take solvent use and industrial process as the examples. For solvent use sources, the discrepancies between different sectors are relatively small, while for the industrial process sources, there are tremendous differences from sector to sector. As to the third-level source classification, profiles for most sectors remain highly uncertain in China due to the lack of localized profiles. As the most measured emission source in China, a road mobile source can be used as an example. With emission standards as the third-level classification, the profiles for gasoline vehicles have undergone significant changes. With the rapid decline of alkenes and aromatics, VOCs have increased sharply. However, diesel vehicles are not as regular as gasoline vehicles due to the insufficient research on the different emission standards. We also compared the integrated profiles in China and the SPECIATE database. Basically, lower discrepancies for on-road mobile source, while larger differences for solvent use and the industrial process were found. I'd like to share some enlightenments in the following slides. Firstly, we found there are many important VOC sources still lacking of profiles, such as airplanes, pesticide use, paper, and food manufacturing. In addition, we found that 85% of the profiles in China was sampled by canister and measured by GCFID or GC-mass. Actually, this method cannot accurately capture many VOC species. Moreover, the update of profiles in China is still lacking. Almost half of the profiles were published 5 years ago, especially for biomass burning and road mobile sources. Last but not the least, we would like to emphasize that from the perspective of ozone formation potential, VOCs should also be focused on. In most regions and cities, only VOCs measured by the photochemical assessment monitoring stations, namely PAMS species, were regulated. We found the unregulated species were responsible for more than 50% for non-road mobile source and biomass burning, and almost the total of all the formation potential for cooking source. In addition, the dataset contained more species and subsectors than the previously developed database. However, the ozone formation potential of the unregulated species are increased in all emission sources. With more and more species measured, the proportion of unregulated species may be more crucial for ozone formation potential, and it is necessary to include VOCs under control. Thanks for your kind attention and listening.